Alright guys, this is on the quadratic formula, which should be familiar to you from Algebra 1. What may not be familiar to you from Algebra 1 is the actual proof, I guess, of where the quadratic formula comes from. So, like it says here, there's a formula that you can use to solve any quadratic equation. We've used factoring so far, we've used completing the square so far, but sometimes even both of those methods fail, and so one surefire way is to use the quadratic formula, which, like I said, once I've got it written down, it will look familiar to you. So, let me write down standard form, which we know looks like this. If we wanted to solve this function by completing the square, we're going to follow the exact same steps that we were doing the other day with the completing the square. First one is, if there's anything in front of the x squared, we have to divide it out. So we're going to start there by dividing both sides by a, and then we'll get a new function. This is going to feel a little bit weird because we've got a, b, and c rather than nice normal numbers, but it still works the exact same way, and we'll get the formula at the end. So ax squared divided by a gives us just an x squared, which is what we need in order for this process to work. And then plus the term in front of x will be b over a, is x, and then plus c over a equals just 0, because 0 divided by a is still 0. All right, next step is that this constant isn't the constant that we need for this process, and so we're going to subtract it over to the other side. Try not to let it freak you out that we have all these weird letters all over the place. So now we've got x squared plus b over a times x. Leave a little space because we're going to complete the square, and then we have a negative c over a on the other side. All right, so side work here, because we need to figure out what that constant is going to be that completes the square, and we are going to follow the exact same process that we did before. So let me do a little side work here. So start with b over a, so you take your middle term, cut it in half. So when I cut that in half, I get b over 2a, and then I square it. Okay, so when I take this and I square it, I square b, and I get b squared. And then I square 2a, so 2a times 2a gives me 4a squared. So that is the constant that I'm going to add to both sides. Again, try not to let it freak you out that it's just all these weird numbers. Oops, sorry. Okay, so that's where we're at so far. On the left-hand side, that is now a perfect square trinomial. Half of this number is the square root of this number, so we can write it as a binomial squared. And we know from the other day with completing the square, the number that goes in here is always half of this number. So half of this number is b over 2a. Okay, and then here, we need to be able to combine these up, and so we need a common denominator. Well, this is just an a, this is a 4a squared. That means our common denominator would be a 4a squared. So we can multiply this by 4a, multiply this by 4a. Okay, so over on the right-hand side, our common denominator is a 4a squared. I'm going to write this b squared first, just because it's positive, and then a negative. Here we have 4 times a times c. Okay, so that's where we're at so far. Next step that we always take, we're trying to get the x by itself, and so we take the square root of both sides. So we have x plus b over 2a equals, whenever we take the square root of the right-hand side, we always start with a plus or minus. There's nothing we can do to simplify that numerator, so I am just going to write it out like this. And then when we take the square root of the denominator, square root of 4 is 2, square root of a squared is a. So we are just about done here. Last thing is I'm going to subtract the b over 2a from both sides. So I get x equals negative b over 2a plus or minus square root of b squared minus 4ac, and that's over 2a. Last thing, so now hopefully this is starting to look familiar for you. So right down here I am going to write the final version of this formula. The solutions are x equals, see here how they're both a denominator of 4 or 2a, we can combine them up over a common denominator. So we have negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Alright, so however you learned it, this formula should look familiar for you, and I've got a little song that we can go over in class tomorrow as well. Okay, so we're going to go through a handful of examples, not every single one of them, just because I think it's, once we figure out how the quadratic formula works, we don't need to see it over and over and over again. So first thing, very importantly, is we need our equation to be in standard form before we try to plug anything into the quadratic formula. All right, so standard form means that I have everything over on the left-hand side and just a 0 on the right. So this becomes x squared plus 6x minus 16 equals 0. Okay, so when I am in that form, a is technically a 1, because there's a 1 in front of this x squared. B is 6, there's a 6 in front of the x, and then c is a negative 16. That is my constant that's just hanging out by itself. So whenever I'm looking for a, b, or c in this formula, I'm looking at these three values right here. So to solve, I just plug these three values into this formula right here and simplify it up. So the biggest part of this section is memorizing that formula, all right, which, like I said, I have a song. So negative b, so we plug in this 6, plus or minus square root of b squared, so 6 squared, minus 4 times a is 1, and then times c, which is negative 16. All right, and then all of that over 2a, so 2 times 1. Okay, so a lot of cleanup to do. So we've got negative 6 plus or minus square root of 6 squared is 36. And then 4 times 1, of course, is 1, times negative 16 is a negative 64. So minus a negative 64 ends up being plus. All of that over 2. Okay, so keep cleaning up. Negative 6 plus or minus square root of, that is 100 when I add it together, all over 2. Of course, the square root of 100, that's a perfect square, so square root of 100 is 10, all over 2. So let's clean this up. So negative 6 plus 10, that gives us 4 over 2, or negative 6 minus 10, that gives us negative 16 over 2. So 2 over 2 is 2, or negative 16 over 2 is negative 8. So 2 answers here for my quadratic equation. Remember, for most of these, I'm going to end up with 2 answers. Okay, let's flip and look at the first one from example 2. Okay, so this guy right here. 2 part A. Solve each equation using the quadratic formula. So I'm going to write the quadratic formula just so we've got it in the shot. Okay, and we are just going to plug in these values. So for this equation right here, a again is 1. There's technically a 1 in front of the x squared. B is a negative 16, and then c is 64. All right, so we're going to use those three values, plug them into the formula. So x equals negative b, so negative 16, which comes out to be a positive 16, plus or minus the square root of b squared, so negative 16 squared, minus 4 times 1 times 64. Okay, and then all of that over 2 times 1, which is 2. Okay, so 16 plus or minus square root of negative 16 times negative 16 gives us 256, minus 4 times 1, of course, is 4, times 64 gives us 256. Okay, and then all of that over 2. So 256 minus 256 is just 0, so this whole thing is gone. So I just have 16 plus or minus 0, which is 16, over 2. So all I have is just a single solution of x equals 8. That'll happen sometimes too. Sometimes I come up with just one solution. Sometimes 2, sometimes 1. Let's look down at example 3 part A and see what we get here. So again, we can write down a equals 3, because there's a 3 in front of the x squared this time. B equals 5, and the constant c is 1. So we'll plug all those into the quadratic formula this time. So x equals negative b is a negative 5, plus or minus the square root of b squared. 5 squared is 25, minus 4 times 3 times 1. All of that over 2a. 2 times 3 is 6. Okay, so we need to show some work. Notice I'm already not even showing as much work as I showed the first time, because some of it we know we can do in our head. So negative 5 plus or minus, this is a 12. So 25 minus 12 gives us 13 under the square root, and then over 6. Now, this one's a little different than the other two, because we have no idea what the square root of 13 is. So once we get to this point, if we don't know what we can do with the square root, if we can't simplify it down any farther, we actually just leave our answer like this. And this is an irrational number. It's technically 2 answers, kind of rolled into one. We've got negative 5 plus root 13 over 6, and we've got negative 5 minus root 13 over 6. Now, I want you to leave it like this. Sometimes the back of the book writes it as a decimal. I don't like that. I want to write it in its exact square root form, so please leave it just like this. Okay, and next one, example 4. Same exact thing, same exact formula. So a is 3, that's the coefficient on x squared. b is 5, that's the coefficient on x, and then c is 4, that is the constant hanging out by itself. Okay, so x equals negative b, we start with a negative 5, plus or minus square root of b squared, 5 squared is 25, minus 4 times a is 3, times c is 4. And all of that over 2a, 2 times 3 is 6. Okay, so clean this up. Start with this stuff right here. So negative 5 plus or minus square root of 25 minus, we've got 4 times 3 is 12, times 4 is 48. Over 6, clean up that square root one more time. So negative 5 plus or minus square root of 25 minus 48 gives us a negative 23. Over 6. So you'll notice we've got a negative underneath the square root. Whenever we have a negative under the square root, that means we're dealing with imaginary numbers. So look at this, the 23 part of it though. It's not a perfect square. There's nothing that we can factor out of it. We can factor out the negative 1. So we leave a 23 here, and then we have an I in our answer, the imaginary number, over 6. And again, since we can't simplify that square root, we actually just leave our answer exactly like that. So it's two answers, the plus version and the minus version, and those are two complex answers because I have the I involved. Okay, so kind of get a little sampling of each, and what I want us to look back on is kind of notice what my function looked like, what my equation looked like, and what kind of answers I got in the end. So starting with example 1, part A, I came up with two nice, normal, whole number, rational answers, really pretty answers. And the reason is, if you look here, underneath the square root, I had 100. Very nice, perfect square value. Okay, so if that happened, my square root of 100 came out to be a nice normal value. That's why my answers came out to be nice normal values. That's one option. Next example. Example 2, part A. Underneath the square root, I got a 0. And because the value under the square root was 0, this term was 0, I only had one answer. So when this thing under the square root is 0, I only come up with one nice, neat, normal answer. Example 3. This stuff under the square root was a 13. It's an integer, but it's not a perfect square, and so I still came up with two answers, but they were these gross, irrational square root answers, not nice, neat answers like example 1 gave me. And then my last possibility here, the number under the square root was a negative, and because the number under a square root was negative, I ended up with imaginary answers, complex answers that had an I in there. Okay, so that leads us to our next topic, which is called the discriminant, and that has to do with what's underneath the square root. All right, so the discriminant, we've got a definition here, and it's just what I was talking about. It's that part underneath the square root. So the discriminant is the expression b squared minus 4ac. And like I said, that is the part under the square root in the quadratic formula. Okay, the piece under the square root in the quadratic formula. And like I was just going over with you, depending on what's underneath the square root, that's going to tell us how many solutions I get and what type of solutions they are. So we've got 4 different possibilities based on the 4 different examples that we just talked about. So 4 possibilities, starting with possibility number 1. This is, let's say that b squared minus 4ac, the discriminant, say it comes out to be something positive. We saw a couple different examples with that. And the important part is that it's a perfect square. Okay, so say it comes out to be a nice, positive, perfect square. If that is the case, we get 2 answers, and they are nice, rational numbers. So we get 2 rational roots if that's the case. This is the best case scenario. Those are those nice, pretty answers like we got in example number 1. We could also have a case where the discriminant does come out positive, so I know I'm going to get my 2 answers, but the discriminant is something that's not a perfect square, like we had with 13 in example 3. If it's not a perfect square, I still get my 2 answers, 2 different. I get the plus version and the minus version, but these roots are going to be irrational roots. Okay, in a sample graph that we can look at, let's say, and it doesn't matter if this graph is right side up or upside down or whatever, but say my graph just looks something like this. I have 2 roots, aka 2 x-intercepts. Maybe they're rational, maybe they're irrational, but the important part is if I have something positive underneath the square root, I have 2 roots. The fact of whether it's a perfect square or not tells me if my answers are rational or irrational. Okay, next option that we saw in the front. If my discriminant comes out to be exactly equal to 0. Okay, and I'm going to flip you back real quick just to show you what happened there. With example 2, part A, my discriminant, that's the piece under the square root, came out to be exactly 0, and because that happened, I added and subtracted 0, which is still 16, and so I only came out with one normal answer there. And it's a nice, neat, rational answer, but I only have one of them. Okay, so if this is the case, if I have one rational root, that means I have one x-intercept. So this is the situation where my parabola comes down, hits the x-axis, but then bounces off it. It doesn't actually cross through, it just has one root right there, sitting right on the x-axis. And then my last option is if my discriminant came out to be something negative, something less than 0. And that happened with our very last example. And so if this is the case, we have 2 answers, but they are these complex answers that have imaginary numbers. So if I have 2 complex roots, that means I don't have any real roots, which means I don't have any real x-intercepts. And so if that's the case, this is when my parabola is either entirely below or entirely above the x-axis, and it never crosses through the x-axis at all, which is why I don't have any real roots, I just have 2 complex roots. All right, so we're going to look at a couple of examples here. We want to talk about what type of roots we're going to get, rational, irrational, or complex, and how many we're going to get, either 1 or 2. All right, so we find the value of the discriminant. We don't need to go through and do the entire quadratic formula. That's a mistake I see a lot. People will do too much work for this. All we need to do is find the value of the discriminant. So just the b squared minus 4ac part. So b is 8. So 8 squared minus 4 times negative 5 for a, and then times negative 1 for b. So we're going to simplify this whole thing up. So 8 squared is 64, and then minus 4 times negative 5 is negative 20, times negative 1 is positive 20. So 64 minus 20 is 44. So let's see which one of these categories it falls in. So 44. 44 is greater than or equal to 0, but it's not a perfect square. Okay, so it's not in this category. It's greater than 0, yes, and it's not a perfect square. Okay, so I think it falls into this category. Let's double check. 44 is not equal to 0. 44 is not less than 0. So 44 falls into this category right here. So that means that this is the answer that I give. I'm going to have 2 roots because it's a positive number that I have under the square root. But that 44 does not simplify into a nice, normal, rational number. And so I'm going to have 2 irrational roots. Okay, next one I'm doing the exact same thing. B squared minus 4ac. Now be very, very careful with this one because these terms are out of order. So here the b is actually the negative 7. It's always the coefficient attached to x. So b squared minus 4, a is 15 because that's what we've got right here attached to the x squared, and then times c, which is negative 4. Okay, so negative 7 squared is 49, and then minus 4 times 15 is 60, and then times negative 4 would be a negative 240. Okay, so add those together because minus a negative becomes plus a positive, and I've got 289. Now we probably are not familiar enough with 289 to know whether it's a perfect square or not, so try to take the square root. See if we can take the square root of 289. Now of course I don't have my calculator with me, which is stupid, but I'm just going to do a little iPhone math here. So plug in 289 and then try to take the square root. We've got this button right here. And it comes out to be a perfect square. It's 17 squared, as it turns out. So if we look back to these categories, it falls in this category. 289 is a positive number and it's a perfect square. So that means that I have 2 rational roots because the square root part will come out all nice and neat. And so that means I'm going to have nice normal numbers, nothing that's stuck under a square root and nothing that's imaginary. Okay, flip to the next page. And so we've got just a little chart here that you can look at. This kind of sums up everything we've done with solving quadratic equations. The first thing that we did was the graphing method. It's not a great method just because it's not super accurate. It only works if you fall on a rational number. We only use this before to say like, oh, it falls between -3 and -2. And it's got this nice kind of breakdown of when you should use each answer. So it's really just good to check your answer and then to use only if you don't need the exact answer. And then you can say just when it falls between. Factoring. You can only use factoring sometimes. You can only use this if you can factor down very nicely, which plenty of things are not easily factorable. The square root property you can only use if you've got a perfect square trinomial, when you have a perfect square like this. Completing the square you can use anytime you want. Just remember that some of them get ugly. And the quadratic formula you can use anytime you want. It's a good thing to use when you've tried factoring, you've tried to complete the square, and it's just not working out. So see the example they gave you here where you've got these ugly answers? That would be a great time to use the quadratic formula. All right, so that'll do it.